how to write to hdfs from a Spark job. In this tutorial, I'm going to read what we wrote in the previous tutorial. Just to quickly recap, if you go to the main menu in the Hue, Hadoop User Experience screen, and click on this and then click on Files, that will give you the hdfs view. And in the hdfs view, inside the learn-hdfs, I had to click on it twice. And you can see orders by cast from Spark CSV. This is what we wrote to. And there will be a part file. Inside the part file, you will see a couple of entries. So 1, 2, 3 John, 4, 5, 6 Peter. Now in this Spark job, we will read from this particular folder. So it's a very simple Java class. So you're creating a Spark conf and giving it a name as Spark Simple. We could give it a name as Spark to read from hdfs, so you can easily identify what this job is doing in the Spark UI. And the file path, so this is the path to the file we just saw earlier in Hue. That's the path up to here. You don't have to put the file name, up to the folder path. So that's a folder, because you can have multiple path files, can be 100. So if you put the folder level, it will read all the files that are sitting under that particular folder. And then from the Spark context, there's a method called text file that will read that particular path and read them into an RDD, resilient distributed data sets. And all this code up to here will be running in the Spark driver. You know that we have Spark driver and Spark executor in the Spark architecture. You can have multiple executors. You can divide the job into different chunks and give it to each executor to process in parallel. So that is basically the parallel processing. Now when you do this rdd.4reach, and this will be happening inside the executor, and then we are just printing whatever we read from the file. So now first I need to left click on the simple Spark job, right click on it and run as Maven install. So this will basically run the Maven install command, and it will build up the jar file, which is a Java archive file. And this Java archive file will be going into the target folder. So this is what we built earlier on. So simple-spark 1.0 snapshot jar. Once you have built this, I'll go to a terminal window. I already run this before. So you run this particular Spark submit command. I'm running on the yarn. Deploy mode is cluster. I'm providing lesser memory for both, 128 megabytes each for the executor and the driver memory. If I leave that out, these options, it'll be 1 GB each. And this is the class that I'm going to do, Spark to read from hdfs. That's what we wrote. And that's the jar file we just built. So when I run this, and it'll give you, like the previous time I ran, it'll give you a URL where you can go and look at the jobs, because it'll be writing, because we are running in the yarn cluster mode, you can only go into the Spark UI screen to see the output, because we are printing it here. So I'm going to kick off this job first, and you can see the println outline, it's inside the executor. So whatever it outputs, we need to go into the yarn UI to see what is outputting. So while the job is being run, if I want to now run this in a local mode, all I have to do is same as the last time, set master, and here I say local, and here you can say asterisk to say run any number of threads, or you can say 1 to run with one executor thread, and so on. So I click on that, I save it, and the other part I have to do is provide a full path for the hdfs. So I put the hdfs as a protocol, then it is quick start dot Cloudera, and the 8020 is the port where the name node is running. So hdfs quick start Cloudera 8020, and then the folder where you're going to read it from. So this should be suffice to run it in local mode. So let's go and see where the job is. It's still in running mode, still running. While it's running, I can open another terminal window and then change directory to etc Hadoop conf. Missed the F here. So do ls ltr. Then I'm going to do a cat on core site.xml. So here I can see what the name node is. core-site.xml, and then I just pipe it to more so I can so fs default fs. So this is the quick start.cloudera 8020. This is the name node. So hdfs quick start Cloudera 8020, that's what we used here. Quick start Cloudera should be 8020, and that's the path. So here I just noticed it's gone from accepted running to accepted and then back into running. So that normally is an indication that something has failed and is retrying the job again. So in that kind of scenarios, what I normally do is, it could be struggling for the resources, so I just exit out of my Eclipse. If you want to kill any job, you can always go into Hue browser, and there's a job browser window which will display the application ID and the job. You can select the checkbox on the left, and then you can kill the job if you want to stop it from running. So in this case, let's demonstrate that. So I'm going to go into job browser. So this is already gone into, so I'm close this window as well. So there's only window here now. So actually job has finished and the job has failed. So this job has this is failed. So this is the last run. So I'm going to kick this job again, because now that I have exit out of Eclipse, see the job is starting now. It's in accepted state. I go back to my job browser. I can't see anything in here, so refresh this again. Normally it refreshes by itself, but there is a time lapse. It's in accepted state still. So now you can see the job is running. Progress is 10%. That's the application ID. So the job is still running. So the job has failed again, so it's worthwhile now going inspecting why it has failed. So I'm going to copy this, and we can go into the UI screen, and then we can investigate why the job has failed. So Control C, I go into the browser, open another new tab, and paste that it hasn't been copied. So go back again, copy, and paste the URL. So this should bring up the Spark UI screen. So here it says it's failed. It has tried a few times and then it has failed. So if I click on the details and see if I can get any details out of here, there are no details here. I can then drill into for each. Executor loss failed, diagnostics container killed on request, reason container marked as failed. Okay, so it's mostly look like it's a resource issue, struggling to run. So I'm going to look at the standard out error. Connection from Quickstart Cloudera are closed. Okay, so mostly it looks like it's timed out. Connection required, quick start, connection, quick start. Okay, so it's basically it's a timeout resource issue. There's a problem when you run it with less memory. But let's quickly look at bring the Eclipse back, and I'm going to look at running it in the local mode. So double click on Eclipse, open the Eclipse up. So the Eclipse is back up here. So this is in local mode now. So I'm going to go into Simple Spark and I'm going to run it within Eclipse. It's always handy to run the job within Eclipse first, iron out any issues, and then package it up and then deploy it to Yarn cluster. So this is a Spark read from hdfs code. So right click on it and then I'm going to say run as Java application. You can also put breakpoints and say debug as. So this should be reading that file which is already in the hdfs, which is under that particular folder. So even though it says .csv, it's basically a folder that will have a number of different part files. So now you can see the output here. It's the initialization code of the Spark. Here we go. So these were 1, 2, 3 John, 4, 5, 6 Peter. So basically it has printed out what is in the file in Hughes. So I'm going to go into Cloudera Manager now, and also I'm going to exit out of the Eclipse. Now we have already run this in the local mode. And let me revert it back to the yarn mode. So this, remove this as well. So save it. Run as Maven install. Probably there's another trick could be I could also restrict the number of executors that's going to run. So maybe after I have read the input RDD, I can also coalesce here to a single partition. So there'll be only one executor. The more executors will run, the more memory is going to consume. So I'm going to do a coalesce here to a single partition. So these are immutable, so you need to assign it to something before you invoke on it, or you do something like that, because otherwise it wouldn't work, because these input RDDs are immutable objects. So I save this, I run as Maven install again, and while it's running I'm going to go into Cloudera Manager, and I might be able to stop Hive, I might be able to stop Scoop. We're not going to use any Scoop, so stop the Scoop. Scoop 2 also can be stopped. I can't stop Yarn because Yarn is sitting on top of hdfs, and Yarn is the one we are running our Spark job on, so they'll close that. The Zookeeper is used by HBase, so for the time being I can stop this. The Scoop 2 also I might be able to stop. Hoop is stopped, and hpace also I can stop. So when we are going to do a tutorial on hpace, then we need to have this hpace running. So I'm going to exit out of Eclipse also, and also I'm stopping the hpace here. So hpace will have the hpace master and the number of region nodes, so it has to go and stop all the region nodes as well. So this might give you a little bit more resource. Okay, the hpace stop failed because we have stopped the zookeeper. So I'm going to start the zookeeper, and then I'm going to stop the hpace and then the zookeeper. So hpace make use of the zookeeper. So the hpace has started again. I'm going to close this. Sorry, the zookeeper has started again. So I'm going to go into hpace. Okay, hpace is already, it says hpace is already stopped. Is it direct hdfs? Okay, yeah, hpace is stopped, so I should be able to stop the zookeeper now. Sometimes some of the services, if you stop them and they're not meant to, they rely on other services, then certain services are not going to work properly. So let's go back here. I'm going to clear this out and then see if I can run the Spark job on Yarn again. So it's saying preparing the resources for our AM container. Then it goes into the accepted state, and when the resources are available, Yarn is going to look at, yes, now you're ready to run. So from accepted state, it goes into a running state, and then from the running state, everything goes well, it becomes completed. So we have stopped quite a few services now. Zookeeper is using the Uzi also can be stopped, which is a workflow manager. Uzi workflow is for scheduling the job. It's like a cron job that we normally run on a Unix system. So if you want to schedule your Spark jobs, then you can use Uzi. So this job is running, so I want to make sure it doesn't go from running to accepted again. That means it's retrying and it has failed. See, now the job has run. So that tells me that previously it has failed because of resource constraints. So now the job has run. Now I can copy this URL and then I can go into Spark UI and check the console output. Or alternatively, I can go to the history server and look for the application ID from this history server that will show you all the different Spark jobs that were run. And I drill down into the job I'm interested in, and then I can inspect it via this Spark UI screen. So I'm going to close this. I'm going to open a new browser. I'm going to paste this URL. So that will give me, see, now it has run. Stages successful, 1 out of 1, 1 out of 1. And I'm going to go into the executors, and the output will be in the executor thread. So here, see, it's only driver. See, once I set my coalesce to 1 instead of 2 or 3 executors that run parallelly on a different data, now you only got 1 executor because I'm just combining them into 1, and that also serves memory. So storage memory is 6.4 megabytes is being used. And then now if I go into the standard out, I should be able to see the output that it read. Here we go, 1 2 3 John and 4 5 6 Peter. So that's the output of the executor. And if you look at the output of the driver, there won't be anything. And if you want to output anything in the driver, you put it outside the RDD. So when you're performing some function like rdd.map or rdd.forEach, that bit of code is going to be executed inside the executor. anything outside, if you put system.out.println, then that will be executed by the driver. So the way the big data is handled is, in a traditional systems, what you do is you bring the data to your code. So when you are running a Java application, you go to your database, read all the code, bring it into memory, then you process them. That is a traditional way of doing ETL. You're using Spring or whatever. You might be using multi-threading, but you basically bring the data to the code which is running. But in Hadoop, in hdfs, what you are basically doing is the code that runs on the executor is going to the data where the data is, because hdfs is where we might 100 nodes, and your same data, say you have a 1 terabyte file, that could be split into different blocks, and different blocks will be sitting on the different machines, and within this different machine there could be one, or it can have 2 or more hard drives, and the blocks all spread. And then when you run a Spark job, all these RDDs, they are distributed. So the data is sitting in a distributed system in 100 nodes. And the code is, we are basically shipping the code from your driver into the executor. And that is the map part. So when you have heard of a map reduce, basically Spark is essentially doing a map reduce job, but it does it in memory and a bit more efficient. It doesn't save the results in every stages between the map and the reduce stages and so on. So the map is processing on that chunk of data, and then when you perform aggregate options like count and so on, that's a reduce phase, and it has to take all the data from different hdfs blocks and then combine them into the final result. So that's why you get the map phase and the reduce phase. So that's all for this tutorial. So we were able to read it in both yarn mode and in the local mode. In yarn mode, because running with the limited resources, was struggling a bit, so I had to go via the Cloudera manager and stop a few services that are not required, for like Hive. I wasn't going to use Hive now. In the next tutorial we might be looking at Hive, HBase, Zookeeper and so on, but you should not be stopping hdfs, Spark or yarn, because it is required to run a yarn job. And hdfs, you should never stop it, because that's a basis for building the whole big data. Thanks for watching this, and we'll meet in a different video tutorial.